Okay, hello everyone. So yes, I'm Marc Laval. I'm a software engineer at Amadeus, so here in France. Not in the grey part of France in Paris, but in the sunny French Riviera. So, and today I want to tell you a bit more about rendering in Angular and the different features that it brings to you. This may be something that you're not aware of today, but okay. So after this conference, all these nice talks, you're quite familiar, I guess, with Angular, especially even if you were not knowing anything about it before coming. So I guess all these concepts which are on the screen, like components, modules, directives, dependency injection, change detection, all this, you know it quite well. But maybe there's one thing that you don't know is how the rendering of an Angular application is done. So what's the architecture of Angular? So basically, when you're creating an application, I guess most of you for the web, so you're using all those concepts. So you're writing your components, you're using Angular. So this is what I call the application. So the code that you write, the code that comes from Angular. You've got all your directives, your components, your logic, your store, whatever, everything together. But at some point, you want to have some DOM being rendered on the screen on your website, right? But so, do you have any idea how the application is rendering, creating those DOM elements? Can you raise your hand if you know? I don't know. Good. One person. Cool. So it would be a useful talk. Okay, so basically the application doesn't touch the DOM directly. So everything is delegated to something in the middle, which is a renderer. And so in that case, it's a DOM renderer. So this is the part of your application, which is basically going to change the DOM, which is going to manipulate the DOM. So which means that your application, so your components, your directives, everything, the change detection, all that, doesn't know at all how it's going to be rendered. It just assumes that there is a tree of native elements that is going to be generated somehow, that those elements can be created, can be destroyed, can be moved around inside the tree, that those elements have properties that can be updated, that those elements can emit some events, but that's it, basically. And so all this is delegated to a renderer. And the renderer itself is quite dumb. It doesn't know what the application is doing, it doesn't know the context, it doesn't know anything about the logic. It just receives basic instructions from the application to create or manipulate the DOM. So let's have a look at the interface of the renderer. So the goal here is not that you learn it, but just to show you that there are about 20 different instructions that can be sent. And so the first set is about manipulating elements and creating them, moving them, destroying them. There are a few methods to attach event listeners, either on an element or globally. And then there are a bunch of methods to update those elements, updating a property and attributes. And finally, there are a few methods to invoke actions on an element. So if you think DOM, for example, it could be like blur or focus. And there's also one last method, which is to animate an element. So this is all. Basically, you've got like those 20 methods, which are basically the interface between your application and the renderer is taking care of every changes in your DOM. So one thing that you can see on the interface is that all those methods are fully asynchronous. So that's the first thing to note. And the other thing is that those methods doesn't return anything except when there is a creation of an element which is done. And so that you can see here that those methods can return anything. It can be a reference to the native element itself, or it can be just an ID. So which means that this interface can be completely serializable. And this is very interesting because it means that if you've got an interface which is serializable and fully asynchronous, we can do multi-threading with it. And to do that in the web environment, basically, you can do it with a webworker. So basically, it means you can run Angular 2 application inside a webworker, keep the DOM renderer inside the UI thread, the main UI threads that you know, and have a communication with post messages, fully asynchronous, serializable between the two, and so that you can get multi-threading and a big improvement in performance. So that's the first feature that this architecture offers. So now, if we can run Angular 2 application inside a web worker, it basically means we can run it anywhere. We just need a JavaScript engine. The web worker cannot access the DOM, just executing some JavaScript. So if we can do it in a web worker, we can do it also in Node, for example. So we can do it server-side. And with maybe a slightly different renderer, we can do server-side rendering, which means in that case, what we do is that on your server, you just run the Angular application with a different renderer, which is instead of, for sure, it's not going to manipulate the DOM directly, but maybe, for example, creating a string representation of your HTML. And so you can do server-side rendering with Angular. And so this is basically what is behind Angular Universal, so Wasim was presenting in today earlier. And so this is why you get this big performance in initial load and the compatibility with search engine and the social links. And so, okay, and all this is thanks to this rendering architecture. Okay, so something which I already kind of showed here or starting to touch is that you can swap renderer. So basically it means that when you run the Angular application, you can just choose which renderer you want to attach to it, basically. And so this is basically super easy. You can just use dependency injection so that when you bootstrap your application, you just provide a different renderer and it's going to work. So you may not use it every day, or you think you're not using it every day, or I hope you're using it every day, because when you write tests in Angular and you use the testing features of Angular, basically you've got a special renderer, which is a debug DOM renderer. So it's basically just extending the default DOM renderer and just doing some more things so that can be useful for your test. So for example, so basically what you get by default from the DOM renderer is this element ref object, which is just a wrapper around the native element. So you can see here the native element. And now there is this anything. It can be anything. So this is a thing which is given back by the renderer. But when you're in debug mode, you've got another object, which is a debug element, which also contains a reference to the native element, but also some useful properties. You can access to the classes which are on the elements, to the attributes. You have a few methods to query inside your subtree of elements. And so it's very useful to write your test. And so all this is just possible because you can just use a special debug renderer for your application when you run your test, and you can take advantage of this. Okay, so we've just seen some nice feature of this rendering architecture, so web worker, server-side rendering, being able to swap renderer and do this debug. But here we've been always speaking about the DOM and HTML, basically having a renderer which is targeting web. But we can go a bit more, can be a bit more fancy than this, and imagine some renderers which are targeting something different. And basically, we can build custom renderers for Angular. And sorry, so custom renderers for Angular. And so when I discovered that, like this feature about a year ago, I wanted to play with it. And so I created something very ambitious, which is a rich text renderer. So which is basically, you can use it to write a full Angular 2 application, which is just outputting a string of rich text. For example, markdown, in that case, even. Let's make it even simpler. So as I was telling, to do a renderer, you first need a tree of native elements. So when you do markdown string, you don't really have this tree, so you can just create a fake tree, fake data structure, which is a tree, which is going to be updated by Angular. And then once you've got your tree ready, you can just run a kind of visitor to just output the string. But as a user, what do you write to do your markdown application or to use this renderer? Well, you would just write an Angular 2 usual component with a template, and the template would be, in that case, something like this. So you've got some special tag names, like this header one here, or bold, hyperlink, etc. You can see that you still can use fully Angular 2 with interpolation. binding to an attribute, ngIf, ngFor. So that's just normal Angular for you. Nothing new, no new concept, basically, just special tags. And you can attach this template for your component. You get a class or so, which is just defining, in that case, a bunch of properties. And after, define also in the constructor set timeout, which is going to change those properties after 1 second. And so if you run that, so you can run it in Node. You can even run it in a browser if you want to, even if in that case we don't use the DOM part, we just use the JavaScript engine. And so if you run it, you get a very nice markdown string. So the header one was transformed into the hash space hello world. You can see the bold, you can see some links, everything is valid. And after 1 second, the set timeout will fire. And so, so it's still an Angular 2 application. So Zone.js is going to intercept the set timeout. It's going to trigger change detection, and then the string will be updated. And after 1 second, you get something like this. And so you can see that the ngIf condition became false, so one line disappeared. There is one more item in the array, so now you've got 4 items here. And so basically, with this, you can build complex, full application, Angular 2 application, which is generating Markdown. And you can go even a bit more crazy. You can have, for example, you could use Angular 2 HTTP module to get some data from a backend and use it to generate your Markdown and whatever you can imagine. So this is interesting, right? It shows, it's a good exercise to show how renderer works in Angular and how you can do your custom thing. It's not very useful though, so let's try to see something a bit more interesting. So here we were targeting a different rendering target environment, which is just a string, string. So maybe we could do the same thing, trying to render a native mobile application. And so this is basically what is being done by Telerik and with NativeScript. So NativeScript is a way to build native applications in JavaScript, and with a special renderer, you can use Angular to build those applications. And so you can do it with NativeScript, and there is also an more like experimental project, which is doing the same with React Native. And so I'm going to show you a bit more, let's dive a bit more into this React Native approach. Okay, so to understand how it works, and we first need to have a look at how any React Native application is working, basically. And so the architecture for React Native application is, basically there are 2 parts. So on one side, so on your right side, there is the native, let's say, there is some native code which is running in 2 different threads, and this native code for sure has access to the platform APIs, to the platform UI components, and it can just create create some native elements and do whatever it wants. And also inside React Native application, you've got a JavaScript thread in which you can execute any JavaScript code. And so those 2 sides basically communicate thanks to a bridge. And so which means that on the JavaScript side, you've got some APIs that you can use. And so from JavaScript, you can access the platform APIs and the platform components. And so if you know how to use this kind of low-level APIs, then you can just write, you can build a native application with React Native with just some basic JavaScript. So you don't need React, you don't need Angular, you don't need any framework to do that, or Cycle.js even. There's some bridge also for that. So basically the code will look something like this. So you get this UI manager object from React Native, you can import it, and then you'll use it to create some elements or to attach them to a tree of elements, and then it's going to render. So just an hello world. So it works. It's not super useful because as a developer, you don't want to write this kind of code for sure. But let's have a look, let's step back and have a look at the situation. So we have a tree of thanks to React Native, we can build a tree of native components, which can be created, moved around, which can be updated. They have some properties also, which can be updated. In React Native, we can run a JavaScript application, any JavaScript application. And so that's a perfect match for a renderer, right? Because we can just take basic, any React Native application, and inside the JS thread, run the Angular 2, run an Angular 2 application. And here it's really like an Angular 2 application, like any application, just normal application. And then, for sure, we need a special renderer so that when Angular wants to create an element or want to update an element, then there is this renderer will know how to use those bridge APIs and how to create those elements. Okay, and so there's just one thing is that you can see here there's a special arrow which is basically the application using the API directly. So it's not because the meaning here is not that the Angular application is manipulating the elements directly, but there are some APIs which are accessible from this bridge, which can, for example, if you want to create an alert, if you want to access geolocation, if you want to access network state, or this kind of things, it's also available through this bridge. And so this, you can use it directly from the application. So React Native supports iOS and Android, so let's have a look at what we can do with Angular and React Native. So I couldn't find a way to zoom this properly, sorry. It's a bit small, but here you've got two simulators. So on the left side it's iOS, on the right side it's an Android one. And so this is the application, like a kitchen sink application, which is part of the renderer repository. So you can build it yourself if you want to. And so we can see that we've got native components like scroll views. We have some tab bar on iOS, slider, switch, a lot of different things, date picker here, a map view, and on Android we also get the same, sometimes the same components, like the scroll view would be exactly the same. So we don't have really the tab bar in Android, but you've got this pager view, for example. Oops, sorry. Again, some sliders, so you can see it's really the native elements. And if you want to feel it's native, you can just start playing with this. And here it's a navigator from iOS, and you can see the details. Well, it's a native element, so really the animation and the movement is really what you get from a native development. And on Android, you can also see it with this drawer component, which is that if you're used to Android, you know it well because you get it in most applications. So for sure, with this, we can access APIs. So I'm mentioning, for example, alert. So you can use alert, and so this is a native alert from iOS. Nothing crazy, but it's great to do it directly from JavaScript. We've got also the same kind of APIs on Android. Well, it looks differently for sure because it's Android native. Okay, and if you put all this together, you can build small applications like a to-do MVC where you can listen to events, update the UI, and yep. And in that case, it's even better because those elements which are used in this to-do MVC are quite generic, so like it's just view and text and basic elements, so they are exactly the same on iOS and Android. So here it's exactly the same code which is running on Android and iOS for this to-do MVC. So there is nothing special. We can also listen to gestures like having some tap or swipe or like this. So after that, so listening to a tap in your application would be as easy as listening to a click on your web application. So, we can use HTTP also from Angular. So if I'm searching for something on Wikipedia, I can get some pages. So here, just using the regular HTTP module from Angular. And on both sides, all the navigation is managed by the Angular router. So again, it's nothing special, nothing new to learn. And okay, and it's still in both cases, it's still a React Native application, so you still have access to the debug tools or development tools of React Native, so that you can reload or you can even debug the JavaScript directly inside Chrome. So it's quite interesting. Okay, so oops, sorry. Okay, so that's it for the demo. So here so that was an example really. For sure, it's more advanced than the markdown text renderer. But so here we can use this rendering architecture to really build native applications, and you can do the same with native script. So as a user, when you're writing such an application, then you're just going to write a regular Angular 2 application. It's nothing new. Again, it's like for the markdown. You just write your usual components with your template and your class, and the components, for sure you won't be using some HTML elements, but you will be using a special set of components which are available for the platform. For React Native, the styling is a bit specific, so it's not based on CSS, but it's based on some properties that you can apply to elements. But again, so gestures are there. So I was mentioning gestures, so listening to a tap is just as easy as that. So basically, you're just using the full Angular 2 features, including the router and HTTP, the same syntax, the same directives, like this ng-if, and you use that to build a native application. And for sure, you can also access the React Native APIs. So I was mentioning alerts. So if you wanted to show an alert here, you would just import alert from React Native and just do alert.show with some parameters, and that would be it. So all of this to say that this rendering architecture is really something great, because you can really build your own renderer, which you can imagine like targeting anything. Could be creative, I don't know. Do some music with a special renderer, for example. Maybe it's for your next talk. Do some 3D rendering with some, I don't know, Unity engine or whatever. But the good thing is that if you change a renderer, you keep your skill of Angular 2, you keep your knowledge of Angular 2. You can still use HTTP, you can still use all those features of Angular, the syntax. You can just still project components into others and do those crazy things. And in the case that you're building the same application for different targets, you can really share code between the different targets. Because, for example, if you got a service which is accessing your backend and processing some data using HTTP, well, you can just use the very same code to do it for each different target. Okay, so if you want to try all these renderers which I've been showing or mentioning, you can go to, they're all in GitHub, and so there is a very simple one for the rich text renderer, which is, if you're interested, you can have a look at it. It's like hopefully the simplest renderer possible. If you're interested into native script, which covers much more than this React Native one, because it really covers much more components and APIs than the one with React Native, you can have a look at their project. And if you're still interested in this React Native one, go to Angular/React Native renderer in GitHub. Okay, so that's it for me. So my handle on Twitter is Marc Laval, so I will be tweeting those slides in a few minutes. And thank you.